All right, hi everyone. Uh, so this is the beginning of a series for studying for the FE exam, and what we're going to start off with is just regular mathematics and algebra, and these are for straight lines. You'll notice in the FE handbook they break. I'll show y'all here. They break, math into different sections. Of course, they have finite state machines, your million, more circuit state machines here. In mathematics, they start with discrete math, matrix of relationships, so your matrices, your graphs, and then they get into straight line, more algebra based things. So, what we're going to be doing is we're going to be starting with the straight line first. And so, this question asks or gives us two different straight line equations. And it's asking first, where do the lines intersect? So, the way we figure this out is let's draw our xy graph. We have 3x plus 6. I mean, this can be very arbitrary. I'm just going to draw 3x plus 6, and 1 half x minus 4, so something like this, right? And so we know it's going to be, this is of course not drawn to scale, so realistically it could be up here, it could be up here, it could be anywhere. This is just to show y'all what we're looking for. We're looking for this point here. To find this point, we need to set the equations equal to each other. So now you solve for x. So you can add 4 and subtract 3. So we get 10 is equal to minus 2.5x, or negative 7 over, not 7, negative 5 over 2x. So solving for x, multiply by negative 2/5 to both sides. We can see that 10 divided by 5 is 2, so now you get negative 4 is equal to x. So now we know what the x is, but the question doesn't ask what is the x value, it's asking where do these intersect. So now what you need to do is you need to plug in x back into the equation. So 3 times negative 4 plus 6, we get negative 12 plus 6 is negative 6, and just as a checkup on yourself, plug it back into the other equation. Make sure you still get negative 6. 1 half times negative 4 is negative 2, minus 4 is negative 6 also. So these check out, and we know our answer now for part A is negative 4, negative 6. What about for part 2? It's asking, what is the angle between the two lines at this point of intersection? Okay, so the angle between these two lines, okay, so there is a specific equation we need to use given in this in the handbook. And remember, the handbook you'll be able to use during the exam. They're going to give you a PDF form on the computer that they allow you to take the exam on, and you are going to have to know how to. This is basically your cheat sheet. You're going to have to know. You see how it's 500 pages long. You're going to have an idea about where everything is at. Of course, at the top they give you your table of contents up here, so you'll be able to do it kind of quickly. But remember, even if you click, or even if you go to page 34 in your math section, you're going to have to go through this entire math section, and it's pretty lengthy. You'll have to know where it is. So get accustomed to, going through this and just trying to figure this out. Okay, slope-intercept form, and we notice the equation right there is the angle between lines with slope m1 and m2 is alpha equals the inverse tangent m2 minus m1 divided by 1 plus m2 times m1. So this is equal to tangent inverse. I already forgot it. That's pretty great. M2 minus m1 over 1 plus m2 times m1. Okay, so let's plug in our values. Tangent inverse m2, let's look at our second equation. It's 1 half minus 3 divided by 1 plus 1 half times 3. Okay, you just plug that into your calculator here, and we should get about a minus 45-degree angle. So that's our answer for part 2. Part 3 now. Well, are these lines perpendicular? Well, perpendicular would mean that the angle between the two lines is 90 degrees. Another way to do this is to look at your FE handbook and notice it also says two lines are perpendicular if m1 is equal to negative 1 over m2, or m1 times m2 is equal to negative 1. Of course, we know m2 times m1, 1 half times 3, is equal to 3 over 2, and is not negative 1, so not perpendicular. And that would be our answer. This is how you would solve this in your FE exam. So hopefully this helped y'all. If y'all have any questions, make sure to comment down below. I'm currently making a Word document that goes over every single topic, or the practice problems for every single topic, that we don't have to buy your practice exams. Of course, get the real practice exams. They're really, really good. But I'm going to be making some so that, y'all can get more practice with this. But yeah, hopefully this helped.